Happy day, YouTube. My name is John, and this is my channel, The Intermancer. Let me show you some things I've been working on. A couple of weeks ago, at the time of this recording, Anthropic updated their models to Claude 4 Sonnet and Claude 4 Opus. I didn't notice it at the time, but they also updated how much knowledge you could include in your projects. You can see here that right now I am only using 2% of my project capacity, and that is using all of my source code, main and test, as well as, I'm not happy with that interface, as well as my Gen AI context, all of the context documents that I've been using. How do I go up a level? Anyway, guess that doesn't matter. Ooh, maybe it's that thing. Maybe if I go here, what if I go here? There we go. That's the tree. Here. Okay, so now I'm only using 2%. Earlier, the last time I remember checking, I was using like 15%. So they have definitely updated and expanded how much memory you can use for the project knowledge in your projects, which is a great thing. That's a great thing. Bigger context is usually better, although you always want to try to keep your context as small as reasonably possible, because the smaller the context, the more refined the information you get. But you want to put in there everything that is possibly relevant. So there's always this push-pull with context, something I'm learning. And I'm learning a lot. I want to address real quick the fact that this is intended to highlight my personal learning experience. This is not a tutorial channel. Someone wrote recently on a comment, I deleted their comment. They wrote on a comment that I am years behind. And if your metric is how you are using AI to code quickly, then that is absolutely true. But coding quickly is not my goal here. My goal here is to learn how these large language models work and how to best use them for larger projects. Most of the use of AI for generative AI for coding is done with small kind of toy projects, or things that are mostly web development projects, things that are just, JavaScript or React kind of projects. What I'm doing here on this channel is eventually expected to be a fairly large project that runs on AWS and has a React front end and has a complex back end and uses Docker and all of the things. But I'm doing that one step at a time, and I'm showing all of the steps one at a time. I'm not skipping anything. So this isn't about short little tutorials so much as it is about me showing all of the little things involved in learning how to use AI, not necessarily using generative AI in the most efficient fashion to go as fast as possible. And honestly, I am convinced that going fast as possible is a good way to get yourself into a hole quickly. A lot of other developers on YouTube have made it clear that if you go the full vibe coding route, where you're just working with the LLM, giving it code and taking whatever, or giving it prompts and taking whatever code it gives you, that's a way to end up with an unmanageable pile of mess very quickly. And I'm trying to take the more slow and gentle approach. I know that eventually I'll use some kind of AI supplemented assistant, probably Claude Code. But right now I'm just on the $20 a month plan, and I'm not using an API key, and I'm not going for the $100 a month plan. So I am mostly taking the approach where I describe my system in context documents and then ask the AI to generate pieces for me. So I just wanted to highlight what I'm doing here again, even though I've highlighted it before, because some people seem to think that I am trying to do something similar to what most people are doing, and I'm not. So the first thing was I already highlighted that they've increased the size of your project knowledge with this latest update. That's pretty awesome. But the next thing I want to highlight is that my IDE here, Visual Studio Code, which I'll be honest with you, this is my first experience with Visual Studio Code. I'm not super impressed. I will pay for IntelliJ before I will pay for the max plan of Claude. But right now I am going with the most bare bones approach for all of the tools that I can, and that's Visual Studio Code, which is not a great tool, but it's the tool I'm using. And it is telling me that right here, this gene generator is using a switch block, and it's telling me that I should use a switch expression. I want to highlight that this switch block is what Claude gave me. And this, in turn, highlights the fact that the LLMs are stochastic machines. They work with statistics. They tell you what's most likely based on the training data that they've received. And the data that they've received a lot more of older code bases. Switch expressions are a newer Java concept. And so my IDE is telling me that I should use a switch expression instead of this switch block. The first thing I'm going to do here is I'm going through Claude first. So I'm going to ask Claude to rewrite gene generator to use a switch expression instead of the current switch block. Let's see what it does. Very exciting. A more modern and concise approach available in Java 21. So it's pretty new. And I'm using Java 21, but I don't know Java 21. So I'm having to rely on these tools to tell me how to use the newer code styles. So this is exciting, very exciting. It tells me how to do it. I've successfully updated. The key changes are switch expression syntax, switch block is using arrow syntax, more concise and functional, direct assignment, gene instance, get random gene, okay. Okay. All right, excellent, same functionality. So let's copy this here, go over here, select everything, paste it in, save that, gets rid of the warning. Let's go ahead and push it up to my repo. Updated the switch block to use the more modern switch expression syntax. Commit and push. This is interesting, all this stuff here that has commented out. This is an interesting block. It's planning for the future. I gotta say, this block of commented out code is one of the most interesting things that Claude has done for it. It is anticipating one day where I will have genes that use more than one target index, which is right around the corner, but it's not here yet. And it's planning for that and has the commented out code, which I got to tell you, this is some fascinating emergent behavior. And these LLMs do have interesting emergent behavior, things that you wouldn't expect, even though they are just statistical engines. So this feels like thinking. It's not thinking, but it feels like thinking. So let's move on. At the end of last episode, I did a bunch of code refactoring. Specifically over here in gene and chromosome and organism, I took the generated get mutation command list method that Claude gave me, and I pulled all of the generated mutation commands out into their own methods. Why did I do this? Because I like to read it better this way, only for personal preference, and also because I believe that good code is written for human comprehension, the comprehension and the support of the developers that come after you. There's no reason for me to do this other than lower cognitive friction for those who might read it later. Because see, now this get mutation command list method, it fits on one screen and it's so pretty. Look how pretty all of this is. It just tells you, okay, we're going to add in these target index mutation command, get add down, up, down, constant up, down, operational constant, target index constants. So everything is really clean, very understandable. You go in here, and honestly, I could probably stand to do this because this is just these two methods, for example, only differ by this little sign right here. Boom, boom. So I could probably do this and send in the adjustment and generate here where it just has gets the random number and sends it up like positive or negative, but this is fine. So I'm going to do two things with this now that I did these refactors myself. One, I am going to have the LLM update the context documents to include my refactors so that the context documents reflect my personal preferences, and which that's a questionable value, but that's what I'm going to do. And I also need to write test classes for this. I need to have the LLM write test classes for this. So that's what we're going to do next. So let's see, we did that switch block, so we need to real quick update the project. That doesn't take long. Now, here's an interesting thing. Earlier, if you've been watching, you'll remember that I needed to do I did a design context document, and I had Sonnet and Opus both generate 3 alternatives. I did a real short design document, and then I relied on a lot of the code that I'd already written, all the context documents that I'd already written to provide additional context. And I asked Sonnet and Opus to give me 3 expanded alternatives. And I liked the one that was done. I liked one of the alternatives that Sonnet generated more than I liked the one that Opus generated. So what I'm going to do here, in the name of science, is I am going to have both Sonnet and Opus generate updates to the really it's just going to be the organic classes.md context document. This organic classes context document is the one that has all the information for gene, chromosome, and organism. So that's the one I'm going to update to bring it in line with the code that I've written. So let's do that for both of them. I have updated gene.java chromosome.java and organism.java so that they are easier to read and understand. Rewrite, not rewrite, update, because I don't want a full rewrite. Update organic, why do I have a hard time remembering my own files? Classes.md so that the smaller methods I introduced for get mutation command list, get mutation command list are reflected, are described correctly. Hope that's good. Let's see what it does. Let's see what it does, and then we're going to see what Opus does. Data quantum consumer. Okay, so this is in gene. That went by and I didn't see it. Helper methods. Okay, chromosome. Helper methods. It's introducing this helper methods block. That's nice. I like that. Methods and properties. Helper methods for mutation generation. Okay, I like that. I like that. We're going to do the same thing in Opus and see what it generates. Major updates. Added helper methods. Let's see this. Let's see. Gene. Get mutation, implements the mutation line, or returns a list for each element it calls. Okay. All right. Okay. And then it does the same thing for chromosome. So let's take it. We'll take it. Oh, wait. No, we are going to do this for Opus also. Projects. Gaia F. Research. What's research? I don't even know what that is. I'm not clicking that button though. I'm taking this prompt. I'm putting it here. So before, you'll see here, this is using Sonnet. You see it here. And now I've switched this to Opus. It's using the same project knowledge. Let's see what it generates. I bet Sonnet's going to be fine, and Sonnet's faster and cheaper, so that's what we'll probably use going forward, unless I have good reason to use Opus, mostly for just the speed. Data quantum consumer, gene. Here we go. Look how slower it is. It's significantly slower. Methods and properties. Okay. Okay, so we can see that it didn't give the private helper methods their own section the way Sonnet did. I like Sonnet's method. I like the way Sonnet approaches things. This is interesting to me. This is very interesting to me. But clearly Opus has some advantages because Opus generated a correct class diagram for the system in one shot, whereas Sonnet took 11 tries and I had to tell it what was wrong with its first 10 for it to give me a good one. But then, this is interesting. Okay, so we'll take Sonnets. We'll take Sonnets. Copy this. And go to organic classes. Okay. And that's the only change that's pending. Okay, that's fine. Now then. Now for Opus, I bet the code is better for Opus. We're going to keep the experiment going. We're going to keep the experiment going and comparing Sonnet and Opus while I learn what their individual strengths are. I wish I'd been doing this before when I was back on 3.7, but we're doing it now on 4. Okay, so let's see. Gene.java, chromosome.java, and organism.java have all been, that's what the original prompt said. Have all been updated to include mutation behavior since their respective test classes were written. Rewrite the test classes for each of these Java classes so that they are fully tested. Let's see what that does. Gene test before each. Okay. I don't know that it had a before each before. While it's writing, let's check that out. Test. Gene test. Look, there's no before each here. So that's interesting that it's setting up something for gene. Set up test gene. Test genes.adder gene. Okay. Data quantum. That is interesting. And data quantum, so it adds a test gene and a data quantum gene as fixtures for gene test. A fixture is just stuff that you reuse for every test throughout the thing, and it does the same thing for chromosome. So Claude Sonnet 4 honestly is a step above a Sonnet 3.7 just because it has that behavior, because that gives you a place where you can update how each of the tests methods behaves. Data quantum, chromosome. What? Look at this. This is interesting. This is interesting and weird. Continue. Look, it has chromosome as a fixture here. Okay, I guess we're going to have to wait. Still, that's weird. What I just saw was weird. So we're going to talk about it. Okay, it's looking at organism tests, so we should be able to go back and look at chromosome test. So look, in chromosome test, it has chromosome as a fixture in setup, but these first two methods immediately override that chromosome with a new chromosome. New chromosome. Why would the new chromosome do anything? Oh, it wouldn't do anything. Okay. With no genes. Okay. Why does it? Oh, see, that's an error. It sets up the fixture because it thought to do that, but then it doesn't use that fixture at all. That is interesting. And similarly, I bet this data quantum fixture isn't really used. New data quantum. New data quantum. Huh. So I like that it did a before test method there because it thought, hey, I should have a before test method. But then it doesn't use that anywhere. It doesn't use it anywhere. New chromosome, original chromosome, copied chromosome, test copy of. Okay. Test equals, test hash code, test get mutational, mutation, command list, empty chromosome, mutations dot stream. Why 0? Assert equals 0. I bet this fails, right? Add a random gene, move a random gene. Why would these be 0? These should all be 1. This is interesting. This is fascinating. And this also implies that maybe I'm already stretching it a little bit too far. And the optimal use for the LLMs is to come into the IDE and prompt it for a method by method approach. So real quick, we're just going to copy this. Well, let's do it by the numbers. Gene first. And if this fails, I'm going to try just deleting the fixtures. Copy. Gene test. Organism test. Chromosome test. And organism test. Oh, we got to continue on organism test. Okay, it finished it. It just didn't finish telling me about it. Okay. So let's see what it's got here. Now, my thesis is that the build is going to fail. So let's go ahead and test that thesis. Build. Boom. Test failed. Organism test. Chromosome test didn't fail. Chromosome test. Oh. Okay, delete a random gene with 1. It'll give me an empty mutation. Okay, so first off, let's see. Can we get rid of this fixture? And will this still pass? All right. So that still worked. That's good to know. Makes sense. It still passed without that. What is it saying here? Look at this. The IDE is telling me object equals null is never true. So that makes sense. So we will chromosome 1. Okay, we will just delete all that. Why not? Okay. Now, that was chromosome test. Gene test probably also doesn't need that fixture. So let's go ahead and get rid of that. Disappointing. I thought it was cool that the fixture showed up, but realizing that it's not needed. Oh. Test gene. Test gene. Okay, it's using this one. How many errors does it give? Does it just give the one? Test gene abstract class. I don't think this is giving me anything, so I'm just going to delete it. Let's see if this works. If it does, I'm going to keep it this way. Build successful. That's good to know. And then organism test, same thing. Get rid of the fixture. Is everything fine there? What's it telling me? What are you telling me? Throwable method results is ignored. Okay, whatever. Don't worry about that. Okay, we'll get rid of this. The ID is telling me this is useless, and it's right. Okay. And it's doing stuff for the mutations. I'm honestly going to just trust it at this point. Is that vibe codey? I guess it's a little vibe codey. But if the thing is test running, at this point, I've seen that if it creates a test that passes, it's generally decent. So I'm taking it. And is this good? Is this good? It's good enough. So update all of that. Updated the context doc to include descriptions of helper methods personal aesthetic. Also updated test methods, test classes to test mutation behavior. Commit and push. I think that's enough for today. I've taken a good step forward on some of the code, and so I'm going to call this video done, and I look forward to next time. Thank you.